Welcome to the explainer video for GaussianGraph. GaussianGraph enhances 3D Gaussian-based scene understanding by integrating open-world scene graph generation that can be queried with natural language. Existing 3D Gaussian-based scene understanding methods primarily focus on embedding compressed clip features to 3D Gaussians, suffering from poor segmentation accuracy and lack spatial reasoning. So we associate Gaussian clusters with descriptions and relations, enabling large language models to reason about the target object. Here is an overview of GaussianGraph, given an input sequence of RGB images with poses. GaussianGraph uses segment anything model and grounding deno to detect 2D segmentation and bounding boxes. Through LLVA model, we extract captions and relations from foreground objects plus object pairs. After extracting 2D information, 3DGS algorithm generates Gaussian primitives to reconstruct the scene. In order to segment them, each Gaussian is initialized with instance feature, forming Gaussian clusters through control stage and follow stage. By establishing the correspondence between 2D feature and Gaussian clusters, we construct a 3D scene graph with clip features, attributes, relationships, and distance. Furthermore, we introduce 3D correction modules based on spatial consistency verification to refine the scene graph. The relationships between objects are divided into 4 sorts, corresponding to respective correction submodules. The generated scene graph is stored in the structure on the left. Through LLM reasoning, it can be used for a variety of downstream tasks. In the visual question answering task, the target object and the corresponding node can be inferred based on the spatial relations and object attributes. In the object grounding task, same class distractor in the neighboring area tend to cause interference. GaussianGraph can eliminate distractors through accurate 3D relationships in the scene graph. Here is the visualization of GaussianGraph on the LERF dataset. It demonstrates the view-independent 2D masks and view-consistent feature fields on the upper side. And we compare GaussianGraph with other 3D Gaussian-based methods in the object grounding task. Our GaussianGraph can reason the accurate object category with less artifacts and noise. Appreciate for your watching. We sincerely invite you to check out the project page.